we've got a trapezoid, and we'll just have a look at the flip chart. Okay, so our trapezoid is has a length that we don't know yet, and it's got one end is 2 and the other end is 5, and we're being asked to calculate the area based on the fact that we know that this line is length 13. Okay. Now, firstly, we have to remember the formula for the area of a trapezoid. Average of the bases divided by 2 times the height. Well, we've got the two bases. We've got 2 and 5. If we stand it on its end, then those can be the two bases. So the average of the bases is going to be 3.5. And what we need to calculate is the height. Well, if we look here, we've got a right triangle. And furthermore, we've got a right triangle where we know that one of the sides is 5 and the hypotenuse is 13. Well, once you've been through the mill with these questions a little bit, you're going to immediately recognize that as a 5, 12, 13 right triangle, and therefore the length of this leg of the triangle is 12, and therefore the area is 3.5 times 12, which is 42, and that's the right answer. Okay, so reasonably straightforward question in a way, but you have to see it, and the way that you see it is that you should know that in most geometry questions, when you're being asked to calculate a distance, then you're being asked to calculate a distance based on a Pythagorean triple, and based on the idea that somehow in the diagram you've got a right triangle and that you can use the Pythagorean theorem to get there. So if AB is 13, well, that should immediately make a red flag go up for you that says, right, this is a 5, 12, 13 triangle, and indeed you then look and see that the other, that one of the leg lengths is 5, and that should immediately make you think, right, okay, well, the distance from A to the fourth vertex of the quadrilateral of the trapezoid is 12, and therefore I'm going to be able to plug that into the formula. Okay, so that's a pretty straightforward example of a